What's good, everybody? Professor Peters here. Today we're talking about composite functions. So I'm going to show you guys exactly what that is and how to properly solve them in different scenarios. So it asks us to find f of g and it gives us our two functions. But an important thing for us to know is which one is the outside function and which one is the inside function. So this is another way to write the same exact question. And we need to know that g of x is the inside function, f of x is the outside. So for us to properly solve this question, this is what we're going to need to do. So we have f of g. And right, so what we're going to do, we're going to have f function's on the outside. We're going to plug in g of x, which is x squared minus 1. So now remember that this g function is inside of f. So what we're going to do is we're going to take x squared minus 1 and plug it in for x. So this problem turns into x squared minus 1 plus 7. And for us to finish off this problem, we're just going to combine our like terms to get x squared plus 6. And this is the answer of f of g. But in our second problem, now what they ask us to do is to find g of f. So we are now basically doing the same problem but backwards. So to find g of x, or g of f, I'm sorry, this is what we need to do. So we know the f of x function is x plus 7. So what we're going to do now to x plus 7 is substitute it in for x squared. So we have x plus 7. We're going to square this, then subtract 1. But just remember, this exponent means we're going to expand the binomial. So let's take this up here. So we have x plus 7 multiplied by x plus 7 and then subtract 1. So when we FOIL, right, meaning we're going to multiply, we're going to get x squared plus 14x plus 49 minus 1. And then when we clean this problem up, our final answer is going to be x squared plus 14x plus 48. So this is just the basic finding f of g, g of f. As in our second scenario now, they're asking us to do the same exact thing. Find f of g, but now they put a number value there. So how does this actually change the problem? I'm going to show you guys. So we're going to start off with the same process, right? We have f as the outside function. Let's plug in our g. So now when we plug in g, we have 4 parentheses x minus 3, right? So the difference with this now is before we actually plug this function into f, we have to figure out what g of 3 is. So we're going to actually substitute and solve. So once we substitute, we're going to get f of 0. So now this is very, very important, guys. So after we solve the inside function, we're going to take the output, the answer, right? And now do f of 0. So we're saying to ourselves, when we plug 0 into that f function, what are we going to get? And what we get is negative 70. 0 squared is 0. 3 times 0 is 0. And then we just have negative 70 left over. So when we're working with these type of problems, it's a little bit different. Same process, but we're going to have to solve for g of 3 first, and then that answer, we're going to plug it in for x and then solve the second function. In our second example, what we're going to do now is we switched the function around. So now instead of finding f of g of 3, we're going to find g of f of 3. So similar to the last problem, right? We know g is the outside function. Let's write our inside function. X squared plus 3x minus 70. So now it tells us to evaluate the f function when x is 3. So when I plug in 3 now, this is what I'm going to get. So when we solve f of 3, it's going to give us negative 52 as an answer, right? So now what we're going to do is we're going to do g of negative 52. So I'm going to look at my g function. I'm going to plug 52 into it and see what I get as an output, because this is what functions are. You plug a number in, you get a number out. So we substitute 52, and anywhere I see x, I'm going to put negative 52, and then we just simplify and solve. So this turns out to be 4 times negative 55. And if I'm not mistaken, our final answer should be negative 220. So thank you guys so much for watching this video today. If you found it helpful, we're going to ask that you smash the like button for us.